I'm Anil Kumar sharing with you a test problem. Now, whenever I say I'm sharing with you a test problem, it means that the probability of getting a question very similar or close to one I'm sharing is extremely high. The students who are in grade 12 doing advanced functions, and if they have a unit test 3 coming up this week, then this is the problem they should understand. The question here is, consider the polynomial p of x equals to ax to the power of 4 plus 8x squared with 3 turning points and absolute maximum of 8. Write the polynomial function if it has 0 at x equals to 2 and sketch its graph. So I'd like you to pause the video, answer, and then look into my suggestion. Well, here we have two parts to the question. The first one is we need to write down the equation for the polynomial, and second, we need to sketch it. And therefore, that makes it the right question for Unit 3. Polynomial given to us is p of x equals to a x to the power of 4 plus 8x squared, which has a 0 at x equals to 2. Then x minus 2 is a factor, so p of 2 should be equal to 0, correct? So we'll substitute 2 for x. So we get a 2 to the power of 4 plus 8 2 to the power of 2. That helps to solve the leading coefficient a, correct? So we have a 0, so this p of 2 is 0, is equals to 2 to the power of 16 a plus 2 square is 4, 4 times 8 is 32. Let's solve for a now. Minus 32 equals to 16a, or a equals to minus 32 divided by 16. That gives us the value of a as minus 2. So with this value of a as minus 2, we know what our function is. So let's write down the function, which is the answer to a part of this question. So the polynomial given to us is p of x equals to minus 2 x to the power of 4 plus 8 x squared, correct? Now let us try to sketch it. To sketch, what do we need? We need to understand the leading coefficient, which will give us the end behavior, and the zeros. So let's factor this so that we know exactly where the zeros are and what type of zeros do we have. So we can factor minus 2x squared. That will give us x squared minus 4. And that could be written as minus 2x squared, and x squared minus 4 could be written as x plus 2 times x minus 2, correct? I hope you can see this. Okay, let me push it a bit on the left side. Okay, I think that's very clear. So that gives us 3 zeros, right? So we have, now let's analyze our polynomial. So first part is degree. Now what is the degree of your polynomial? Degree of the polynomial is 4. Now leading coefficient. Leading coefficient is minus 2. Now from here we know basic characteristics of the function, and let's put them on the paper. If the degree is 4 and leading coefficient is minus 2, what can you say about the end behavior? Leading coefficient minus 2 means right side down, right? That is it. 4 is even, both face same side. So that is the end behavior. Is that okay? So we know end behavior. That is when x approaches positive infinity. Let me write down here now. When x approaches negative infinity, or when x approaches positive infinity, y approaches negative infinity for both the cases, correct? So I'm doing a shortcut, but you should write separately for both. That's the end behavior. Now let's read the question once again to sketch it finally. Consider the polynomial p of x with 3 turning points. We have 3 turning points and absolute maximum of 8. So sometimes you may just forget about this. And we have absolute maximum of 8. So let's draw, this is kind of a helpline, just to remind that this value is representing maximum 8. So this point is 8 for us. Our graph has to touch this point, correct? Write the polynomial function if it has a 0 at x equals to 2. That helped us to find the value of a and then sketch it. That's it. So reading the question once again helps you to get it absolutely correct, right? 3 turning points and absolute maximum 8, all these zeros. Okay, now let's analyze zeros and sketch the graph. So what are the zeros? We have one 0 at x equals to 0, that is one of the zeros. The other 2 zeros are at x equals to minus 2 and plus 2. So minus 2 and plus 2. Okay, so these are our zeros. So let me write these things also, which will help you to understand how we sketched it. So let's write down the zeros here. Zeros are at, this one 0 is at 0. Its multiplicity is 2, right? The other one is at minus 2. Let me write here minus 2. Multiplicity is 1, linear 0. The third one is at plus 2, whose multiplicity or order is 1. So those are linear. So these ones are linear. Our graph will cross them like a straight line. This is quadratic. It has to turn, and then it will cross again and come to quadrant 4. So this really helps us to sketch the graph. So now let us sketch the graph. So we need to get to the maximum of 8. So it's a good idea to touch that value and then turn. Do you see that? Turn and then turn from 0, and then you can go like a linear 0 and cross the line. So if you sketch like this, you ensure 3 turning points, 1, 2 and 3, absolute maximum of 8, zeros at, let me write down, zeros at minus 2, 0 and plus 2, and behavior as for negative leading coefficient even degree polynomial, right? I hope with this you understand quite a bit about your unit 3 on polynomials, and if you get this question, write your comments and let me know. I hope you appreciate it. Thank you and all the best.